There's this incredible technology that's quietly reshaping our world. It's working behind the scenes in, well, pretty much everything, from the phone in your pocket to the cars on our roads. It's called computer vision, and it's all about teaching machines how to see. So today, we're going to pull back the curtain and really demystify how this whole thing works. And look, this isn't some futuristic sci-fi concept anymore, is it? It's happening right now. All of it is powered by this remarkable field of AI that's literally teaching machines to see and understand our world, often in ways that are a lot like our own sight. And as you're about to see, it is everywhere. I mean, just take a self-driving car. To navigate safely through a busy street, it has to process this chaotic flood of visual data, and it has to do it instantly. It's using computer vision to identify every single thing, other cars, people walking, traffic lights, and then make those critical, split-second decisions that keep everyone on the road safe. But this technology is way more than just a convenience. It's a potential lifesaver. Seriously. In medicine, computer vision is becoming this invaluable second set of eyes, helping doctors analyze medical images. It can spot tumors or other issues, sometimes with a level of precision that even helps the experts themselves, leading to earlier, more accurate diagnoses. And it's not just these huge life-or-death situations. It's also tackling our everyday hassles. Imagine you get into a little fender bender. Instead of waiting around for an adjuster, you can just snap a few photos of the damage. A computer vision system analyzes it right there on the spot, figures out the repair costs, and gets your insurance claim moving in minutes. It is a total game changer for efficiency. And all this demand, this drive for efficiency across so many different fields, is fueling a massive, massive industry. The computer vision market is projected to hit, get this, a staggering $48.6 billion. So we're not talking about some niche tech for hobbyists. This is a major engine of economic growth. So what's the really crucial point here? Well, computer vision isn't just about giving a machine eyes. That's the easy part. It's about giving it understanding. It's the difference between a camera that just records a street and a self-driving car that knows it needs to stop for a person crossing. That is the incredible leap we're making. And wow, the applications are just exploding across dozens of industries. We're seeing it used to get better crop yields in agriculture, to spot tiny defects on manufacturing lines, even to analyze player performance in pro sports. It's an incredibly versatile tool that's really changing how entire sectors do business. Okay, so we've seen what this stuff can do, but what is computer vision really? At its core. Let's break it down. So, what's the secret sauce? Well, at its heart, computer vision is the part of AI that tries to copy the incredible power of human vision. The goal is to train computers to see the world not as just a jumble of pixels, but as a meaningful scene full of objects, people, and all the context that goes with it. And computer vision doesn't work alone. It's a key piece of the bigger AI puzzle, working hand in hand with things like machine learning and robotics. You can almost think of it as the eyes of the operation, giving robots and other AI systems the ability to actually perceive and interact with the world around them. And the ultimate goal here, it's incredibly ambitious. It's not just to match what a human can see, but like the quote says, to do these things with the same efficiency, if not better. And that's the key part, right? It's about creating systems that can, in some cases, see things that we might miss. So how in the world do we actually teach a machine to do this? Well, the process is surprisingly simple to grasp. You can think of it just like teaching a toddler to recognize different animals. But instead of showing them picture books, we use massive, massive amounts of digital data. Let's just walk through this fruit example. First, you gather the data. You feed a model thousands and thousands of images where every apple is labeled apple, every banana is labeled banana, and so on. Next, you train it. The computer just chews through all that data, learning the specific patterns, the colors, the shapes, the textures that make an apple an apple. And then, here's the magic part. After enough training, it can look at a brand new photo it has never ever seen before and say, with a really high degree of confidence, yep, that's an apple. So where is all of this going? As computer vision gets more and more powerful and more integrated into our lives, we really have to think about the kind of future we're building. This technology holds so much promise, but, and this is a big but, it also raises some really complex and important questions. I mean, the potential upsides are just enormous. By automating tasks that rely on sight, computer vision can slash human error in critical fields, from spotting a flaw on a factory floor to helping out with a medical diagnosis. And that leads directly to better efficiency, faster, smarter decisions, and ultimately better outcomes for all of us. But here's where things get tricky. As we push the boundaries of what these systems can do, we enter much more complex territory. It's one thing to teach a machine to identify a car. That's a pretty straightforward objective task, right? It's a whole different ballgame to ask it to interpret human emotions from a facial expression. That's deeply personal, it's subjective, and that's where the ethical questions really start to pile up.
And this isn't some far-off future thing. We're seeing this evolution happen right now. We've gone from fairly simple stuff, like your phone finding your dog in a photo, to developing systems that try to analyze the tiny subtleties of human expression and behavior. And as the technology gets more capable, it moves into more and more personal areas of our lives.
Yeah, this is absolutely not theoretical anymore. There are systems in use today that claim they can look at your face and infer your emotional state, whether you're happy, sad, or surprised. And this really brings us to the fundamental question for our time, doesn't it? As we give machines this powerful ability to see, what are the limits? Where do we draw the line between helpful assistance and an unwelcome intrusion? It's a huge conversation, and it's one we all need to be a part of as we shape the future of this technology. Thanks for joining me on this one.